The first painting is red, the second is blue, the third is pink, the fourth is green, the fifth is purple, yeah? And then he starts from the beginning. So the sixth is red, the seventh is blue, the eighth is pink, the ninth is green, and the 10th is purple. And we could just keep counting up until we get to 31, and some students might end up actually preferring to do that at first. There's an easier way. What we're essentially doing is we're doing 31 divided by 5. Because there are 1, 2, 3, 4, 5. Every cycle of 5 that he makes is just going to get him right back to red. So all that matters is the remainder. If we do 5 into 31, well, 5 times 6 is 30, and we get a remainder of 1. That remainder tells us where we land. And when I say this is the basis of something called modular arithmetic, I mean that literally. This is something that I studied heavily in college. What if there were only 5 numbers in the world? Well, then all the math would just loop, right? 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, forever and ever. This is that in a much simplified fashion. Again, absolutely love how math is taught these days. So, with that remainder 1, after 30, it's going to be here in purple, yeah? It's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, blah, 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 blah. Number 30 is going to be purple. So 31 is going to be red. Which rule describes the pattern shown? Do we add 12? Do we add 16? Or do we multiply by 4? Oh, or do we multiply by 8? There's another possibility. Back up a little bit further. Okay, well, it looks to me like we're definitely not adding 12. We do add 12 the first time, but the number gets way too big, way too fast for us to be adding 12 every time. Same thing with adding 16. Looks to me like we're multiplying by 4 with every successive number. The table below shows the number of minutes it takes to run laps. If the pattern continues, how many minutes will it take to run 13 laps? So it looks like they started at 35, or it looks like it's, 5 minutes every lap, right? And they're counting up by 5, so 35, 40, 45, 50. So 11 will be 55, then 60, then 65. 65 minutes for 13 laps. I doubt anybody can get their split time that perfectly even, though. The following pattern starts with 5 and uses the rule, multiply the previous term by 3. So that's the rule. The rule is multiply the previous term by 3. Which of the following statements is true? The pattern includes only multiples of 3. Close, but no. 5 itself is not a multiple of 3, but everything else is, right? We multiply by 3 to get whatever, to get the next number. But it's not true that all of them are multiples of 3. But it is true that each number has a 5 in the ones place. We're going to check the other rules, though, just in case. The sum of each number's digits is 9. Well, that's also obviously not true because 5. Also 15. So the answer looks like it's B. Patterns with numbers. I like it when teachers showcase the playful side of numbers and have students solve fun problems instead of just doing a bunch of long division over and over and over again. I like stuff like this.